All right, today we're going to review how to solve a system of linear equations using substitution. So last class we looked at how to find the three different outputs, whether it was no solution due to parallel lines, many solutions due to overlapping lines on top of each other, the same line, or one intersection point. So you are going to practice today graphing a couple of systems. But we're going to start with a new strategy called substitution. And so this is a strategy in order to solve algebraically for x and y for the intersection point. So the first step is just look at your two equations. Do you have a variable that is easy to isolate, meaning get it by itself? So actually, this example already has one of the variables that is by itself. So yes, I have x equals 2y minus 8. X is already by itself. So our next step is to substitute this easy variable, x, so this stuff over here, 2y minus 8, into the other equation where you see the x. So we're going to put this equivalent expression in for x in the other equation, because you can't solve an equation if you have two variables. But if I get all the same variable in one equation, then I'm able to solve for either x or solve for y. So in this case, my new equation over here is going to become 2y minus 4 times parentheses. Instead of writing x, I'm going to write 2y minus 8, close parentheses, equals negative 4. So I'm going to use the distributive property here to start solving for that harder variable, which is solving for y. So I have 2y minus 8y, because I distribute the 4, plus 32, because negative 4 times negative 8 is positive 32, equals negative 4. Combining like terms gives me negative 6y plus 32 equals negative 4. And subtracting 32 to the other side gives me negative 6y equals negative 36. Dividing by negative 6, y equals 6. So I just completed step 3, solving for the harder variable y. So now I'm going to put the solution for y into either the first equation or the second equation to solve for x. So it would be easiest to put it into the second equation because that is already solved for x equals. So I've got x equals 2 times, I'm plugging in 6, minus 8. So this looks like 12 minus 8. So x has to equal 4. So my solution is 4 comma 6. So that would be the point of intersection of those two lines, and it says you can check your solution. So if I plug in the point 4 comma 6, I know it's going to work over here, right? Because 2 times 6 is 12, minus 8 is 4. But let's make sure that it works over here. So 2 times 6 is 12, minus 4 times 4, so minus 16 is negative 4. It has to make both equations true. So that is solving by substitution. So we're going to do a couple more examples together. So in example 2, none of my variables are by itself, but the easiest one to get by itself is this y in the second equation. It's already almost by itself. All I have to do is subtract 25 to the other side. So I've got that y is equal to 2x minus 25. So if y is the variable that I'm choosing, I'm going to circle where that y is in the first equation. This bubble is going to get plugged in where that y is because these are equivalent. So I can substitute in for this y, this expression of x. So now I'm going to rewrite that top equation, but instead of using y, I'm going to use 2x minus 25. So I get 3x minus 4 times parentheses. So instead of y, I'm writing 2x minus 25, close parentheses, equals negative 5. then you're just at the algebra 1 level of solving an equation for one variable. I only have one variable, and that is x. So I get 3x minus 8x plus 100 equals negative 5. Combine like terms gives me negative 5x plus 100 equals negative 5. Subtract 100 to the other side. That gives me that negative 5x equals negative 105. Divide by negative 5. I think that is 21. Does that sound right? 105 divided by 5. So positive 21, because a negative divided by a negative is a positive. So that is only half of my solution. I have one of my solutions for my variable. Now I need to plug that back in, either to the first equation, the second equation, or how about our modified equation? Our modified equation, wherever that bubble is, that's where you want to plug it into. That would be the easiest. So if I plug 21 in and evaluate, I'm going to get right out of that what y has to be. So y equals 2 times 21 minus 25. So 42 minus 25 is how much? 42 minus 25 is 17. So y has to be 17, and for good measure, it's nice to write your final answer as the coordinate 21 comma 17 because it's a point of intersection. So that was a little bit harder. We had to solve for one of the variables at the beginning. All right, so my next example here, I could choose, either this y or this y to get by itself. Doesn't really matter. So I'm just going to pick the first equation. So if I add 2x to the other side, I would get that y equals 2x plus 7. So I'm going to take this 2x plus 7 and plug it in for the y in the second equation. So I would get negative 2x plus 2x plus 7 equals 10. So something a little bit different happens here. My variables add up to 0, negative 2x and positive 2x. So I get a statement that 7 is equal to 10. Is that a true statement or false statement? That's false. 7 can never equal 10. So this tells me that there's no solution to this system of equations. So what situation gave us no solution? It was parallel lines. And if I had actually put the second equation into slope-intercept form by adding 2x to the other side, wouldn't I get y equals 2x plus 10? And I already had y equals 2x plus 7. So I had parallel lines with different y-intercepts. So I can never get an x value, y value that lie on both lines. The lines are literally going to be laying next to each other. Nothing over here will ever line up with something that's over here. So there's no solution. So that's what no solution looks like algebraically. You get a constant equal to a different constant. So it's a non-true statement. All right, the last example before you do some practice on your own, I need to pick one of my variables to get by itself. So you could either choose this y here, or you could maybe choose this y here, anything that's going to not give you a bunch of decimals. So let's choose this top equation here. So I would subtract 10x to the other side to start with. 10x, need a pencil. Negative 10x plus 100. So I have negative y equals negative x plus 100. And then I would actually have to divide my entire equation through by negative 1 so that I truly do have y by itself. So my equation is that y has to equal positive 10x minus 100. So this is what is going to get plugged into the second equation's y. And you could have solved for x. I just happened to keep solving for y because it's the easier variable, I guess, for these examples. So let's see, I have 2 times parenthesis 10x minus 100 minus 20x equals negative 200. So now I'm going to solve for x. 20x minus 200 minus 20x equals negative 200. Something similar happens to last time. When I add my like terms together, they add up to 0. And I get that negative 200 equals negative 200. A constant is equal to another constant, which is true. So if you get a true statement and all your x's are gone, what that means is there are many solutions. All the points that lie on this line will also lie on this line because they are the same line. So if I had put this other equation into slope-intercept form, I would have added 20x to the other side and divided by 2. So see how it also get y equals 10x minus 100? So these are the exact same equation, just one is multiplied by a different factor. So this is going to be the same line on top of each other. So the solution is many solutions. All the points that are on one line are also on the other line. So now you're going to try to complete, you've got 2 different graphs, and then you've got 3 different problems with substitution. So if you get stuck, I do want to see your work done out for each one so that I could maybe give you direction on where you're making your mistakes, or maybe I'll see that you're all set and you know how to do substitution well. So please show your work, and you're going to take a picture and upload it to the assignment that's posted on Google Classroom. Thanks.